In 1998, a 43-year-old woman in Iowa was operating a punch press at a machining facility on a hot June afternoon. She had worked at the plant for 6 months. The press was a simple machine. It held an upper die and a lower die, and when she stepped on the foot treadle, the ram came down with several tons of force, punching a shape out of a sheet of metal. The cutout piece, called a knockout, was supposed to drop through the die into a scrap tray below. This time, the knockout did not drop. It stuck. She reached in to clear it. What happened next took less than a quarter second. The ram came down again. The investigation could not determine whether she accidentally bumped the foot pedal or whether the press repeated on a mechanical fault. But the press cycled and the ram struck her in the chest. She was transported to the hospital and pronounced dead 90 minutes later. The scrap tray that should have caught the knockout had been removed from the machine, defeating the one barrier between the operator and the point of operation. She was killed by a piece of scrap metal that should have fallen through a hole. That was the punch press. A machine so fundamental to modern manufacturing that every car you have ever driven, every appliance in your kitchen, every steel cabinet, filing drawer, and electrical box was born from one. And a machine so efficient at destroying the hands of the people who operated it that federal safety investigators called it the leading cause of workplace amputations in America. If you want to see which machine I cover next, subscribe and drop it in the comments. The concept behind the punch press is ancient. People have been stamping metal since the Lydians minted the first coins in the 7th century BC, pressing gold and silver blanks between two engraved dies with a hammer blow. In 1550, a German silversmith named Mark Schwab built the first screw press for coining, using a massive screw mechanism turned by as many as 12 men to force the dies together. King Henry II of France imported Schwab's machines, but the process remained muscle-powered and slow for 300 years. It was the Industrial Revolution that turned a coining tool into a killing machine. In the mid-1840s, an American inventor named Joseph Francis built steam-powered presses capable of stamping large sheets of iron into corrugated shapes for boat hulls. Around 1870, the American company Bliss and Williams began marketing the first eccentric mechanical presses, machines that used a motor-driven flywheel, a crankshaft, and a connecting rod to convert spinning motion into a violent downward stroke. These presses could punch holes through half-inch steel plate at 100 strokes per minute. In 1890, a German bicycle manufacturer discovered that stamping parts from sheet metal was faster and cheaper than forging or casting them. Suddenly, every factory wanted presses. By the time Henry Ford opened his Highland Park plant in 1910, rows of stamping presses were punching out crankcases, fenders, and body panels for the Model T. Ford resisted the technology at first. His engineers had to convince him that stamped steel parts were as good as die-forged ones. But when his factory could not keep up with demand, Ford had no choice. By 1914, Highland Park had 15,000 machine tools, many of them stamping presses, producing parts for a car that rolled off the line every 93 minutes. The punch press did not just serve the auto industry, it built it. Here is how the machine worked, and here is why it took so many hands. A mechanical punch press has a heavy iron frame shaped like the letter C, with a flat bed at the bottom and a ram that slides up and down at the top. The ram is connected by a pitman arm to a crankshaft, which is connected through a clutch to a spinning flywheel. The flywheel stores the energy of an electric motor and spins continuously. When the operator triggers the clutch, the flywheel's energy is transferred to the crankshaft, which drives the ram downward. A punch attached to the ram slams through the sheet metal and into a matching die below. The entire stroke happens in a fraction of a second. Now here is the critical part. On older machines, which dominated American factories for most of the 20th century, the clutch was what engineers call a full revolution type. Once the operator tripped it by stepping on a foot treadle or pressing a palm button, The clutch engaged, and the crankshaft completed an entire 360-degree revolution before it could stop. The ram went down, came back up, and only then returned to rest. There was no emergency stop. There was no way to interrupt the stroke. If the operator's hand was inside the die when the treadle was pressed, whether by the operator's own foot, by a falling object, or by a coworker bumping the pedal, the ram completed its full cycle regardless. By the time the human brain registered the mistake, the metal had already closed. Could you imagine standing at a machine for 8 hours, reaching your hand into the same gap 500 times a shift, knowing the machine cannot stop once it starts? If you can, let me know in the comments. The operator's daily task was numbingly repetitive and extraordinarily dangerous. Take a blank sheet of metal from the stack. Place it on the lower die, position it precisely. Pull your hands back, step on the foot treadle, the ram drops, the punch cuts, the finished piece ejects, or the operator reaches back in to remove it. Repeat. In high-volume operations, the press might cycle at 60, 80, or 100 strokes per minute. The operator's hands were in and out of the point of operation with every single stroke. Everything depended on the operator pulling free before the ram closed. The safety margin was measured in milliseconds. The foot treadle that controlled the press was the worst possible design for this task. The operator's hands and feet were doing two completely different things. The hands were reaching into the die space. The foot was hovering over the pedal that would bring the ram down into that same space. A slip of the foot while the hands were still inside was the textbook path to amputation. The data proved it. An OSHA report covering injuries from 1975 to 1983 found that of 2,908 reported mechanical power press injuries, 62% involved foot-controlled presses. Only 30% involved hand-activated presses. The most frequent cause of injury listed in the reports was accidental trip of the foot pedal, while the operator's hands were inside the die. The numbers were staggering. In 1980, the Bureau of Census counted approximately 151,000 mechanical press operators working in the United States. Bureau of Labor Statistics data showed that around 20,000 workplace amputations occurred every year nationwide. Of those, between 1,600 and 2,000 happened to power press operators alone. That was 10% of every amputation in every industry in America, from one type of machine. Injury statistics compiled by OSHA found that 49% of all mechanical power press injuries resulted in amputation. Nearly 1 in 2. When a power press hurt you, it did not give you a bruise or a cut. It took a piece of you home with it. A Michigan State University study of work-related amputations found that on average 52 Michigan workers per year lost part of their hand to a press. Workers injured by a press were twice as likely to lose multiple fingers compared to any other type of machine. In 20% of the cases, they lost more than just the fingertips. Males sustained more than 4 times as many amputations as females, and for both sexes, the highest rates hit workers in their 20s. The case reports read like dispatches from a small, invisible war. A 19-year-old male used both hands to unjam a mechanical press. It engaged while his hands were inside. He lost the index, middle ring, and little fingers on his right hand at the base. His left hand was crushed. A 21-year-old female had her left hand caught. 3 fingers were unsalvageable and surgically amputated. A 46-year-old female had her right hand caught in a hydraulic press that possibly malfunctioned. She sustained amputations of 4 fingers. She was unable to remove her hand from the machine until the fingers broke off. A 30-year-old male had 1.9 tons come down on his left hand. 3 fingers were surgically removed. A 44-year-old male had his head crushed in a cycling press during a job setup. The safety devices had not been activated. He died. A 26-year-old male was crushed and killed in a bench draw machine after pressing the wrong button on an unlabeled control panel. The carriage returned at full speed. He had been operating the machine for approximately 3 weeks. You are probably wondering whether safety devices existed. They did. That is what makes the story worse. Engineers developed safety devices over the decades. Barrier guards enclosed the die, but they made loading parts difficult, so operators removed them. Restraint devices strapped an operator's wrists to cables that physically prevented the hands from entering the die, but they required individual adjustment for each worker's arm length, and they were rarely readjusted between shifts. Pullback devices yanked the hands clear when the ram descended. Sweep devices, mechanical arms that swatted the operator's hands out of the way, were eventually banned by OSHA for being unreliable and sometimes injuring the operator. The two-hand control was the breakthrough. The operator had to press and hold two palm buttons simultaneously throughout the downstroke, keeping both hands accounted for on every cycle. However, it only worked on part revolution clutch presses, the newer kind that could stop mid-stroke. On a full revolution press, two-hand controls were useless because the machine could not stop once the stroke began. The light curtain, an invisible grid of infrared beams across the die opening that would halt the press the instant a hand broke a beam, had the same limitation. OSHA's own regulations stated it plainly. Present sensing devices may not be used on machines using full revolution clutches. The most dangerous presses in America could not use the most effective safety technology available. And those old full revolution presses stayed in service for decades. NIOSH published Current Intelligence Bulletin 49 in March 1987, and the findings were damning. Researchers measured the actual hand speeds of press operators and found that 79% of young male operators exceeded the OSHA standard hand speed of 63 inches per second. The fastest hand speed recorded was 142 inches per second, more than double the standard used to calculate safe palm button placement. A young male operator could release the buttons and get his hand into the die before the ram stopped. The safety formula was wrong. The guards were not fast enough to protect the people most likely to get hurt. The problem ran deeper than any single regulation. Operators sometimes defeated safeguards deliberately, removing or overriding guards for convenience or to increase productivity. On machines that stamped differently shaped parts, each of which needed a different guard, it could take more time to install the proper safeguarding than to run the entire job. Pull-out and restraint devices required individual adjustment for each worker's arm length, and that adjustment was frequently skipped between shifts. Employers failed to maintain presses, allowing clutch and brake mechanisms to wear until a press that was supposed to make one stroke would repeat, cycling again when no one had touched the treadle. The repeat stroke, an uninstructed second cycle caused by a worn clutch or a sticky engagement mechanism, was one of the most feared malfunctions in any stamping shop. The operator would trip the press, watch the ram come down and go back up, reach in to retrieve the part, and the ram would come down again on its own. Machine guarding has been one of OSHA's top 10 most frequently cited violations for as long as the list has existed. Fabricated metal product manufacturing, the industry that relies most heavily on punch presses, has consistently led all industries in machine guarding citations. The punch press did not become safe because someone invented a better guard. It became safer, slowly, because the guard was mandated, inspected, and enforced, one shop at a time, one citation at a time, one amputated hand at a time. And even today, with light curtains, two-hand controls, part revolution clutches, and presence sensing interlocks, power press amputations have not been eliminated. OSHA still publishes point-of-operation injury reports for mechanical power presses. The injuries are still coming in: Ohio, Wisconsin, Illinois, Missouri, Pennsylvania. The same manufacturing states, the same cause listed again and again: accidental trip while hands were in the die. The punch press is still the backbone of modern manufacturing. Every sheet metal part in a car, an aircraft, an appliance, a computer chassis, a filing cabinet, an electrical panel passed through a stamping press at some point in its life. Global production runs into the billions of parts per year. The machines are faster now, smarter now, safer now. Servo-driven presses can be programmed to slow down, speed up, dwell, and reverse with digital precision. Automated feeders remove the operator's hands from the equation entirely on high-volume runs. But somewhere in America right now, in a small fabrication shop running short production jobs, an operator is standing at a C-frame press, placing a blank on the lower die, positioning it by hand, pulling back, and stepping on the treadle. The same motion, the same bet, the same fraction of a second separates a finished part from a missing hand. 2,000 times a year, someone loses that bet. Thanks for tuning in. For more stories about the machines that killed the people who worked with them, check the videos on screen. And if you want to see what we investigate next, subscribe.